This is part of the burglar alarm circuit that we developed in the part 2 video. What we have here is basically a latch formed by this NPN transistor and this PNP transistor. Over here we have a timing circuit. So normally all of these bipolar transistors will be in the off condition and will be in a low current standby condition. And our burglar is going to come along and trigger this PNP transistor to come on. And we will develop that circuit shortly. And when this PNP transistor comes on, the voltage at this node goes from 0 volts to a little under 6 volts, about 5.8 volts. And that is going to sound the alarm, and it's going to start this timing circuit. And after about 60 seconds, this capacitor is going to be charged up, the current is going to be diverted into this branch, and our latch is going to turn off, and then our capacitor will discharge through these 3 resistors, and the circuit will reset and be ready for another burglar or whatever. So let's see if we can design a circuit that will trigger this PNP transistor into the on state. Let me erase some of these markings. Let's presume that we have a switch. And this terminal of the switch is tied to ground. So when our intruder comes in, he's going to cause the switch to close, and it's going to short these 2 switch terminals together. And we want that action to cause this PNP transistor to go into the on state and trigger our alarm and sound the siren. So let's consider how we could do this. Let's consider just one component, a simple resistor tied to our switch. Let's make the value 1 k ohm. So when our switch is closed, we'll run a current in this 1 k. That will bias our PNP transistor on and sound the alarm. But there's a problem with the circuit. The problem is that suppose the burglar leaves the switch closed continuously. Well, we're continuously running current in this 1 k resistor, and this PNP transistor remains on because of that. Even though this timing circuit charges up and diverts the current into this branch, this PNP transistor remains on, and our siren never goes off, and after a few hours our neighbors are really angry. So I think we better come up with a little better circuit. So let's come up with a way of making this current go away after a certain amount of time. Let's erase this. Let's put a capacitor in this branch. Now we need to set the voltage on this capacitor, because that's when this switch is open, there's no voltage on this capacitor. It's undefined, and you never want to leave undefined nodes in a circuit. So let's define the voltage by putting a large resistor up to the 6 volt power supply. And this resistor can be quite large. Let's make it 220,000 ohms. So it just sets the initial value on this capacitor terminal. Now what's going to happen when we close the switch? Well, what's going to happen is the voltage is initially 6 volts at this node, and when we close the switch it's going to quickly go to 0 volts. And at the time, just before the switch is closed, this is also sitting at 6 volts. And when we close the switch, we run some instantaneous current in this 1K. That causes this voltage to go down by this base emitter dial drop. And so our voltage goes down to about 5.3 volts because we're dropping 0.7 volts across our emitter base junction. So we could redraw this RC circuit. And let's do that. Let's redraw it this way. And we're going to ground this plate, and we're going to give this resistor a step input that goes from 0 volts to 5.3 volts. So we've connected this circuit a little differently. It's drawn a little differently, but it's essentially equivalent to what's happening up here. So what's going to happen is, let me change colors. This voltage here is going to start at low voltage 0, and it's going to charge up. It's going to charge up to 5.3 volts. And initially, at this time, when we just close our switch, all of the voltage is across this resistor. So we're producing a current in this circuit that's maximum at this time. So if we scroll down a little bit and we plot the voltage across the resistor, when the switch is closed, it goes up high, and then it discharges and comes down. So this is pretty much what we want. Initially, the voltage across this resistor will be 5.3 volts, and if it's a 1K ohm, we'll have 5.3 milliamps. And over time, this current will die down to 0. It's going to go completely away. And so this acts very well as a triggering circuit. So the current in this resistor, when the switch is closed, it goes up to about 5.3 milliamps. Then it falls off according to the RC time constant. And so if this switch stays closed, it really doesn't matter. This current is going to go to 0, and our latch will then be able to turn off, and we won't make angry neighbors.